Hello, we are Group 4, and this is our presentation on Dynamics Homework 1. Our group member consists of Christian Abhipraya Kencham, Hubert Ronaldo Halim, Matthew E. Karangkong, all who have contributed equally to this presentation. Beginning with an introduction, the purpose of this experiment is a drop experiment conducted for the following purposes: to analyze the kinematics of a free-falling object, and to calculate and plot average velocity and average acceleration using video analysis. The task is to perform a drop experiment of an object, of an example, eraser, shoe, tennis ball, etc., and not using an object that is too large for the drop experiment. The goals that are needed to be achieved are plotting the average velocity of the object during the fall, at least 5 points of average velocity, plotting the average acceleration of the object during the fall with 5 points, and recording the experiment using a camera so that you can measure the position of the objects at a certain time during the fall.
Dua, tiga. Okay. Dua, tiga.
The experimental setup consists of a height of fall 2.167 meters, a time of fall of 0.525 seconds over overall fall, and an apparatus using type tape measure, red plastic bag as a parachute of a board eraser which we dropped as the object, and a 10x slow motion camera.
Okay. Dua, tiga.
The resulting video was slow-moed and snapshots were taken. The methodology to calculate the average velocity and average acceleration used the following formulas, where average velocity was calculated by taking the position at one point in the timestamp minus the previous point at the beginning of the timestamp divided by the total time of that particular frame and snapshot. The average acceleration was calculated using the velocity at the end of one snapshot minus the velocity at the beginning of that snapshot divided by the total time it took for the displacement between the two velocities. Therefore, we measured the distance r between snapshots of each slow-mo picture, found the average velocity from fall distance and from each timestamp, and the average acceleration from the velocity and timestamps. These were the following snapshots that were resultant of our breaking down of 5 frames of the overall video. The first snapshot was taken at timestamp from 0 to 0.122 seconds, where the distance between the initial height and the distance where the object is in during the first snapshot is of 0.1376 meters. The second snapshot consists from the first timestamp of 0.122 to the end of 0.225 seconds, where the object has now fallen a total distance of 0.4493 meters. The third snapshot from 0.225 seconds to 0.325 seconds, the object has now fallen a total of 0.8719 seconds. The fourth snapshot consisting of 0.325 seconds and final of 0.423 seconds, where the object has now fallen a total of 1.4086 meters. And finally, the fifth snapshot from 0.423 seconds to 0.525 seconds, where the object has fallen a total of 2.1674 meters. Overall, the following data was acquired, plotting an average velocity versus time graph and an average acceleration versus time graph. By examining the average velocity graph, we can examine that the first, beginning at the height of its before it fall, it had an average velocity of 0, where in snapshot 1, it had an average velocity of negative 1.128 meters per second. In snapshot 2, the object had an average velocity of negative 2 meters per second. In snapshot 3, the object had a negative velocity of 2.683 meters per second, followed by snapshot 4 with negative 3.327 meters per second, and finally negative 7.919 meters per second. Correction, negative 4.130 meters per second. As you can see, the velocity increases over time. This indicates that there is an acceleration for the object that was falling in free fall. The acceleration itself was then plotted for each snapshot, where the average acceleration, beginning with snapshot 1, was negative 9.2448266 meters per second squared, closely nearing the value for the acceleration due to gravity. but then the acceleration decreased to negative 8.487693 meters per second squared, followed by negative 6.8 meters per second squared, 6.54 meters per second squared, and finally 7.9198 meters per second squared. As you can see, the calculated acceleration is getting increasingly lower than the gravitational acceleration in the beginning. The explanation for this can be found due to the fact that we had used a plastic bag acting as a stabilizer, which increased the surface area as the object fall and increased the significant air resistance. This can be attributed similar to how a person falls from a parachute, where if a parachute has a smaller surface area compared to a larger surface area, as the plastic expanded over the fall and the eraser fell, the parachute opened, which means more air pushes against the parachute, which increases the air resistance, which means there is a drag force acting upon the body, and therefore the object would fall slowly, decelerating more slowly, which means there is a decrease of the acceleration due to gravity. Hence why the acceleration decreases over time. Looking at the force analysis, we can see that the net force of the overall object started as the mass times gravity is decelerated due to the drag force caused by the increased air resistance, thus giving the final acceleration lower than gravitational acceleration. Hence, the velocity increases negatively as the object falls, indicating downward motion, where the calculated acceleration is getting increasingly lower due to gravitational acceleration being decreased due to the air stabilizer or parachute attached to the object, and as it falls, as it expanded, the surface area increased, which created an significant air resistance or drag force acting on the object.